Did you see that? It's just so easy to use. No effort at all. The axe is left with just a companion, and the leather surface can only be used to make tools again. The square tube is cut to the appropriate size on the saw bed to make the main beam, with a steel plate added on each side, paired with bearings. The two steel plates are first tack welded to temporarily fix the bearings in place. Mark the screw hole positions, draw the center shaft hole, and align it properly. Then, take it to the lathe to process all the holes. The two steel plates are a bit thick, so using coolant is more stable. Once done, use a standby grinder to remove the tack weld, and with a gentle squat, it splits back into two pieces. There are some burrs, so spin it a few times to scrape them off. Use your toes to gauge the angle and weld it firmly. The other side has the same screw hole, and the overlapping part with the steel beam needs to be drilled through. Slightly tilt it down, and use a tap to thread it properly. Now, place the bearing seat. Secure it with dozens of screws, and then cut the round steel again to make the shaft. Use the saw bed to cut it to the appropriate size. Pick it up and turn both ends flat, then drill a center hole first. Properly position the center point to significantly reduce the wobbling of the rod during processing, and prevent external vibrations. Take it down and sprinkle it into the shaft layer, noticing that it doesn't run too hard. The two remaining boss gears have holes that are too small and need to be addressed. Mount it on the lathe and give it a large drill bit. Push it directly inside to drill through, and adjust the inner diameter to the appropriate size. Just like this, insert the shaft so that it fits snugly. There are too many protruding parts, so remove some of them, and bring the two closer to the drill shaft, securing the outer bearing seat. On this end, there's a shaft sleeve. Just use a rubber mallet to fit it in. A rack. Press down on the top, ensure the two gears are synchronized, and spray some room liquid to prevent welding slag from sticking. First, weld a few points for positioning. Check to ensure there are no issues, and that it can transmit normally before proceeding with continuous welding, making the gear and shaft rod into a single unit. The existing belt flywheel doesn't match the rotating shaft, so a flange needs to be added and connection screws positioned. First, clean the rust off the contact surface, then place the flange in and press it into position. Similarly, use weld points for positioning to prevent movement. Place it on the drilling machine, process all the holes, and then use an angle grinder to remove the weld points. Remove the flange and place it on the drilling machine to enlarge the holes so that the screws can pass through. All the holes on this side are threaded. Position the flange correctly and install 6 connecting screws. Use the lathe to make a quick cut on the tear hole, ensuring it aligns concentrically with the external support, and test it. See that? It's very well done. Drill 3 holes at the connection between the flange and the drill shaft, then thread them and install 3 set screws. This way, there's no need to cut a keyway. Place this ball on top, with the front end electrically extended about 5 miles. Attach a section of square tube at the rear and use a tape measure to mark the position for fixing a high-power motor as the power source. Position the cutting angle iron to service a mounting bracket beneath the installation hole. Mark lines on the inside, mark lines on the outside, and draw circles at both ends. Place it on the lathe's high stand and estimate the path is good. Slowly push the blade forward on the disc to process the installation slot properly. Mainly because I have to get up and go on a business trip, so this is acceptable. Determine the position and weld the bracket to the square tube. A stacking accessory with a grommet is added on the top, matched with a nut at the back. If the belt is too loose, leave the nut on the right to control the motor, and then you can tighten the belt to see if it fits. Once the belt is adjusted, you can fix the motor. Then weld the installation square tube of the elevator to the main beam as a whole, and use 2 steel plates welded at right angles to make the sides of the back. The 2 baffles will not slide left and right. The fixed rod with bearings below will not derail when pushed and pulled, and it is difficult to tilt the 2 racks together. Hello everyone, remember the reporter yesterday? Place another block in front and spray it with room fluid. The connection is solid and will not collapse no matter how you fix it. Add a spacer, fix it with 2 screws, and put the vertebral head together. Add 1 or 2 bearings under the paper strip to make a pulley, and weld 2 modified nuts and a spring underneath. Blow it quickly, then spray it to cool down the spring, to prevent it from losing its elasticity. The spring pushes up the paper strip, and it can be quickly retracted when it is separated from the gear. The push and pull on both sides will not swing left and right. Add a screw rod with 4 bearings, tighten the nut, and add a steel pipe next to it in, and weld the 2 together first. Once assembled, add an extension rod, and weld it as a handle to lift and press down the paper strip. This will engage the upper gears, providing the power to push it back and forth. Add a positioning screw at the front to prevent overextending. The same goes for the front. Just adjust the specific stroke, and you'll have a simple manual clutch device ready. Install a reset spring below the pushing head, so it can quickly return to the starting position. Take a look, it's pretty good, but the impact sound is a bit too loud. Adding a piece of rubber at the back end of the rack will help cushion it. Then, reattach it and adjust the angle of the saw bed to 15 degrees to sharpen the back steel plate for the log splitting blade. Then use an angle grinder to sharpen the edge even more. That's about right. It looks pretty intimidating. A notch is cut out on the main beam, and the blade is placed in and positioned properly. Weld continuously to ensure it's secure. Also change to such a set of wheels to facilitate the transfer of the machine. With a 2-word hydraulic rod, if it is too short, you can set it up, raise it to protect your waist and side, and add a large protective shell to cover the pulley inside, making it safer to operate. The middle part is also covered, making it look more professional. Adding a handle to the steel pipe makes it safer to pull without hurting your hands. Next, spray a nice color on the material tray at the front of the blade. Let's test the line. This piece of wood has a diameter of less than 30 centimeters, and it's ready to be pulled. Continue. Did you see that? It's so powerful, right? This amazing log splitter has the advantage of being super fast, with energy stored in a very heavy flywheel. The razor takes less than a second. You can pull off the pudding glue to lower the machine closer to the ground. Push over a slightly larger piece of wood with a diameter of about 45. It's not too difficult either. Bring it back and place it properly, then continue splitting it. Did you see that? It's just so easy to use. No effort at all. Even though this log splitter operates quickly, you still need to be a bit slower when using it. Safety always comes first.